Hello everyone, this is Solved by Hand channel. In this channel we share videos about problem solving in physics. So in this channel we will solve problems of thermodynamics. We will solve problems of engineering mechanics, both in statics and dynamics. We will solve problems of mechanics of materials. We will solve problems of structural analysis, and we will solve problems of fluid mechanics. The video of today is about significant figures. So, without further delay, let's go to our paper and start using our pen. So, let's go to our paper. And let's go. So we will talk about significant figures. So first thing first. So we'll write for note 1. Note 1. The number of significant figures the number of significant figures down. So the number of significant figures contained in any number contained in any number determines the accuracy of the number. Determines the accuracy of the number. And we will see one example. Let's see example 1. We'll write example 1. In this example, we'll see the number. We'll see one number. We'll see the number 4981, which is 4981. So let's see the significant numbers in this number. So we have 4981. It has 4 significant numbers. Why 4? Why we have 4 significant numbers? We have 1, 2, 3, 4. So 4 significant numbers. So this was about note 1. So let's go to another note, which is note 2. So we'll see note 2. In note 2, if zeros occur at the end of a whole number, so if zeros occur at the end of a whole number so we can see that it may be unclear as to how many significant figures the number represents. So we can write down it may be unclear as to how many significant figures the number represents. So in note 1 we have seen that the number of significant figures contained in any number determines the accuracy of the number, and we have seen an example, the example of 4981. In note 2 we can say that if zeros occur at the end of a whole number, it may be unclear as to how many significant figures the number represents. And we will see an example to understand that. So we'll see example, so that we'll call example number 2. So this is example number 2. Example number 2. In this example we'll see the number. We'll see another number which is 123400, which is 23,400. So we'll see the example of this number. So if we speak about this number, so 23400 this number can have 3 significant figures. For example, if we are talking about 2, 3, 4, so this one has 3 significant numbers, or it can have 4 significant numbers, significant figures. For example, if we are talking about 2340, which is, or it can have 5 significant figures. For example, if we are talking about 23400, so for the example of this number, which is 22,400, it can have 3 significant figures. If we talk about 234, so it has 3 significant figures, or it can have 4 significant figures. For example, if we are talking about 2340, or it can have 5 significant figures if we are talking about 23,400. So 3 significant figures, 1, 2, 3, 4 significant figures, 1, 2, 3, 4, and 5 significant figures, which is 2, 3, 4, 0, 0, which is 5 significant figures. So we have seen note 1 about significant figures. We have seen note 2 about significant figures. So let's move and see another note. So I will highlight this. I will highlight. We have seen note 1. We have seen note 2. In these two notes, we have seen two examples, which are example 1 and example 2. So always about the subject of significant numbers or significant figures, we will move and see other notes. Now we'll see note 3. So to speak about note 3, we speak about note 3. So for note 3, I will write: to avoid these ambiguities, we will use engineering notation to report a result. This requires that numbers be rounded off to appropriate number of significant digits and then express it in multiples of 10 to the power 3, such as 10 to the power 3, 10 to the power 6, or 10 to the power minus 9. So we will write, so to avoid these ambiguities, we will use engineering notation. Engineering notation, and I will highlight, I will underline engineering notation with a red pen. So to avoid the ambiguities, we will use engineering notation to report a result. To report a result. To report a result. This requires that numbers be rounded off. This requires that numbers be rounded off. To appropriate number of significant digits. To an appropriate number of significant digits. digits, and then express it in multiples of 10 to the power 3 such as 10 to the power 3, 10 to the power 6, or 10 to the power minus 9. And with this note we'll see an example, which is example 3. So let's see example 3. In this example we will see the number, we'll see another number which is the same number that we have seen in example 2, which is still 23,400. So we study this example. So this number, which is 23,400, so if it has 5 significant figures, so if it has 5 significant figures, we can write it as 23,400 times power 10 times 10 to the power 3. So if it has, so if this number, so if the number 23,400, so if it has 5 significant numbers, so using the engineering notation, we can write it as 23,400 times 10 to the power 3. So 5 significant figures. So the number has 5 significant figures, so we can write it like this. 5 significant figures means 1, 2, 3, 4, 5. So we can write it like this. 5 significant figures. We can write the number in engineering notation in this way. But if the number has 3 significant figures, so if the number has 3 significant figures, for example, if it has 3 significant we can write it in this way. We can write it as 23.4 times 10 to the power 3. So this is the engineering notation of the number 23,400, but when we write it in this way, it has 3 significant numbers. So 1, 2, 3, 3 significant numbers, 3. But we can see that both numbers will give us the same number. So if we will do the multiplication here, so this one will give us, so here we have a dot, here we have dots. So this way we have a dot here. So both when writing the number in both ways, we will have the same result. So this multiplied by 10 to the power 3, it will give us 23,400. And in the same way, if we write the number with this engineer notation, we'll have here in the result 23,400. The only difference in these two writing is that in the first writing we wrote the number 23,400 using 5 significant numbers, but in the second way of writing the number 23,400 we wrote it using 3 significant numbers, which is 1, 2, 3 significant numbers. Again, I will highlight note 3. I will highlight note 3 that we have seen here, and I will highlight example 3 that we have just seen. Example 3. So the example 3, I will highlight it here. So we have seen note 1, note 2, note 3. Now it's time to move to see another note. Now we will see note 4. So for note 4 I will use another paper. So for note 4 I will use another paper. And I will start writing. So for note 4, note 4, we'll see note 4. Note 4 says that if zeros occur at the beginning of a number that is less than 1, then zeros are not significant. So this is note 4. If zeros occur at the beginning of a number, we'll move this down. Yes, if zeros occur at the beginning of a number that is less than 1, then zeros are not significant. So this is note 4. So note 4 says that if zeros occur at the beginning of a number that is less than 1, so if zeros occur at the beginning of a number, that is less than 1, then zeros are not significant. And to understand that, we will see an example. So we will see example 4. In this example, we will talk about the number 0.00821. So let's talk about this number. So this number, which is 0.00821, it has 3 significant figures. Why it has 3 significant figures? It has 3 significant figures because if we go here, so we can find 1, 2, 3. which means it has 3 significant numbers. And note 4 says that if zeros occur at the beginning of the number, like in this example, so here zeros occur at the beginning of the number. So if zeros occur at the beginning of a number that is less than 1, so this number is less than 1, and it has zeros that are at the beginning, so this 0 and this 1, so these zeros are not significant, so this one we are not significant. So when counting the significant figures, we don't count these ones, we count only these ones. So those are zeros and the number is less than 1. So when looking for significant numbers, we don't count this one, so we count only this one. So this number has 3 significant figures, 1, 2, 3. It has 3 significant figures. Using engineering notation, this number is expressed as, we can express this number as, so using engineering notation, this number is expressed as is expressed as, so we can write this number using engineering notation, we can write it like this: 8.21 to the power multiplied by 10 multiplied by 10 to the power minus 3. So this one has 3 significant, it has 3 significant figures. So we can count here, so 1, 2, 3, which means it has 3 significant figures. Still in this note, which is note 4, we'll see another example. We'll see another example, which is example 5. So example 5. So in this example, we'll talk about another number. So we'll speak about the number 0.000582. So we'll speak about the number. Let's see how many significant numbers this number has. So we can write this number. So this one 0.000582. So this one has 3 significant figures. So it has 3 significant figures. Why? So because this number is less than 1, so the zeros which are at the beginning of the number, they are not significant, so we don't count them when counting the significant numbers. So the zeros are not significant, the number is less than 1, so the zeros which are at the beginning of the number, they are not significant, so we don't count them. So we count only this 1, 2, 3. So this number has 3 significant numbers. Again, so in this example, so let's continue with this example. Also, so I will take another paper. So this is example, we are still in example 5. Continued. So we are still in example 5. So the example of the number so I will move this down. So we are still in the example of the number 0.000582. So using engineering notation, this number is expressed as so using engineering notation, this number can be expressed as, so we can use in engineering notation, we can express this number as, so there are two ways we can write it like this. We can write it in this way: 0.582 times 10 to the power minus 3, which means it has 3 significant figures. We can count them, so we can count how many significant figures. So the number is less than 1, so the zeros at the beginning, they are not significant, so we count only the other numbers. So we count only this number and this number and this one, which means it has 3 significant figures. So 3 significant figures. So this was one way of writing this number. We can write it again in another way. So we can still using the engineering notation, we can write the same number in this way. We can write it so we can write it as 582 times 10 to the power minus 6, this way, and the number has still 3 significant figures, and we can count these significant figures like this. So 1, 2, 3, it has 3 significant figures. So that's all for the topic of today. So that's all for the topic of this video. This example finishes our discussion about significant figures. Thank you. So this example finishes our discussion about significant figures. So if you have liked this video and want to support Solved by Hand channel, click on subscribe button. So we can click on subscribe button here. So you can click if you want to support this channel. After subscribing to Solved by Hand channel, you will start receiving notifications whenever a new video is published by Solved by Hand channel. Also, you can like the channel by clicking on the like button. So you can go and click on like. So you can click on the like button here. So if you want to subscribe, you subscribe by clicking on this button. And if you want to like the video, you can click here on like. And if you want to share this video on the social media, you can click on the share button. So you can go here and click on share. So you can share this video on the social media. You can click here. And lastly, whether you like or dislike the video, leave me a comment. You can go here and add a comment. So you can go here and write your comment. And I will be very happy to hear about what you think about my videos. So that's all for today. Take care and see you next time in another video of Solved by Hand channel. Bye.